fun learning with me. Some fun learning with me.
The universe is filled with stars, each an enormous fiery ball of swirling gases, one of many billions in countless galaxies. From Earth, great galaxies appear as mere glowing specks against the darkness of space. How the universe emerged into a wondrous order of stars, solar systems, and galaxies is a mystery. We believe that our galaxy, the Milky Way, was formed more than 10 billion years ago. Light takes over 100,000 years to travel across the Milky Way. Near the Milky Way's edge is an ordinary star with 9 planets. We call it the Sun. Its gravity holds our small Earth and the other planets in orbit. In the dark emptiness of space, the Sun and planets form our solar system. At the outer edge of this system is a remote planet, Pluto. Cold, dark, nearly 4 billion miles from the Sun. In 248 Earth years, Pluto orbits the Sun only once. Nearly 1 billion miles closer to the Sun, Neptune appears bluish, the color due to methane gas in its atmosphere. Next is Neptune's twin planet, Uranus. Saturn, with its wondrous rings, appears as the most spectacular planet in the solar system. The rings are billions of tiny frozen particles clustered together, locked in orbit around the planet's equator. A few satellites have very thin atmospheres, but Titan, Saturn's 6th moon, is the only satellite in the solar system known to have much of an atmosphere. Closer to the Sun is Jupiter. This largest planet in the solar system weighs twice as much as all the other planets combined. Jupiter rotates faster than any other planet. Twelve moons orbit Jupiter. 8 travel in one direction, 4 in the other. Strong winds blow as thick gases evaporate and condense in Jupiter's clouded and stormy atmosphere. More like a star than a planet, Jupiter even releases heat of its own. it gives off more warmth than it receives from the sun. Between Jupiter and the next planet, Mars, thousands of small bodies called asteroids orbit the sun. Ranging in size from pebbles to tiny planets, strangely shaped asteroids travel in a belt over 100 million miles wide. Light reflected from Mars glows red. On the surface are reddish flatlands, ridges, canyons, and craters. Like Earth, Mars has seasons and climate. Winds blow dust high into a thin atmosphere. "93 million miles from the sun is the dazzling blue and white planet, Earth, with its oceans and clouds. Forces gradually have changed its features since its formation about 4.5 billion years ago. Completely surrounded by whirling layers of carbon dioxide clouds, the surface of Venus is hidden from view. The thick atmosphere traps the sun's heat and prevents it from escaping. The surface is scorchingly hot. Each night on Venus lasts 100 Earth days. Mercury is the smallest planet. Because it is closest to the sun, it orbits faster than the others. As Mercury rotates, the portion receiving light sizzles from the sun's burning, blinding glow. Blazing at the center of the solar system is the sun, the source of energy, heat, and light that makes the existence of the planets possible. The sun is enormous. Its diameter is 100 times larger than the diameter of Earth. Terrific heat and pressures within the sun cause the atoms of its main element, hydrogen, to collide and change into helium. This change, called fusion, releases tremendous energy. Finally, in billions of years, the sun will use all its hydrogen and begin to die. Near the end, it will expand to an enormous size and swallow up the inner planets. Finally, it will cool into a small dark ball, endlessly drifting through the blackness of space.
Man lives on an island in space. He calls this island Earth. Earth orbits around a star that is about 93 million miles away. This distance is just right. Earth temperatures are neither too hot nor too cold for man to exist. This star man calls Sun is the hub of our solar system. Our Sun is the space anchor of 9 orbiting planet islands, more than 30 moons, and millions of tons of comets, asteroids, and space debris. It is 8 billion miles across the solar system, a distance difficult to imagine. Earth, with a diameter of only 8,000 miles, is so small as to be almost insignificant. Earth is 1/1,000,000th the size of the solar system. To understand such vast distances and relative sizes, imagine our Sun, with a diameter of 850,000 miles, reduced to the size of this 27-inch ball. Mercury has a relative diameter of only 3/32 of an inch. Venus, Earth, and the other planets range from pebble size to baseball sized globes against a 27-inch sun. To elaborate on the scale of our immense solar system, we'll use this baseball stadium. The sun is placed at home plate. At this scale, however, the closest planet, Mercury, is 5 feet beyond third base. The pathway of Venus is 180 feet from the sun. Earth's orbit is out 250 feet. And Mars is still in the ballpark at 385 feet. The outfield fence represents a belt of orbiting asteroids 100 million miles wide. Even on this scale, however, the other planets are between 1 and 2 miles outside the stadium. These, then, are the relatively vast distances that separate tiny planets traveling counterclockwise about the sun. Although the Earth travels at a tremendous speed, 66,000 miles per hour, it still takes 365 days to complete its orbit about the sun. Whereas Mercury, the innermost planet, takes only 88 Earth days to complete its solar orbit. Similarly, cold, tiny Pluto, the outermost planet, requires nearly 30,472 Earth days, or 248 years. Our solar system is a perfect clock-like mechanism, a calendar that measures time. either by solar orbit or a planet's rotation. Earth rotates on its axis once each 24 hours. Hence, one day. The other planets also rotate, but at different speeds. For example, one day on Venus is longer than 243 days on Earth. One day on Jupiter, however, is only about 10 hours on Earth. It was about 500 years ago that man began to understand such things as the sun is the center of our solar system. The planetary orbits are elliptical. Sir Isaac Newton explained that a body in motion will continue to move in a straight line unless acted upon by another force, such as gravity. Every particle of matter attracts every other particle of matter. Thus, the Earth is attracted, pulled inward toward the sun, but it tries to travel in a straight line. The result? Earth always falls beyond the sun. These natural laws apply to all orbiting bodies. Thus, the delicate suspension and interdependence of the sun, the planets, their moons, and other space matter. For example, the gravitational attraction that holds our moon in orbit is strong enough to lift the waters of the oceans and cause our tides. The moon moves in an elliptical orbit around the Earth. The complete trip takes about 27 1/3 days. When the moon is between the Earth and sun, the moon's shadowed side is toward us. We can't see it. But as the moon moves around Earth, light begins to appear on the lunar surface. From Earth, the moon seems to have a thin crescent shape. As the moon continues its movement, we pass the stage of full moon until it is again in darkness. Occasionally, the moon comes directly behind the Earth and is eclipsed or hidden by the Earth's shadow. And sometimes, the moon is also in direct line with the sun and casts its shadow on Earth. If you were standing in this elusive shadow as it streaks across the Earth, you wouldn't be able to see the sun, and thus you would be witnessing a solar eclipse. But then, just minutes later, the shadow passes, revealing the sun. Our sun, like all stars, is a great nuclear fusion furnace. Each second, millions of tons of atoms are smashed and their particles are ejected into space. Traveling at millions of miles per hour, this deadly radiation blows upon the planets like a solar wind. The sun also emits rays. Visible rays we see as light. Radio rays we hear as noise. Infrared rays we feel as heat. Ultraviolet and X-rays that can destroy life. The sun is life, warmth, and color. But it is deadly. Man survives because the Earth has a molten core. And as the Earth turns, a magnetic field is created. This magnetic field traps the solar radiation and prevents most of it from reaching Earth. Our atmosphere keeps most of the dangerous solar rays from reaching Earth. Of course, our atmosphere serves in other ways. Most meteorites that come tumbling in on Earth ignite and burn before they hit the surface. Other conditions that make life possible are oxygen to breathe, water to drink, a fertile soil, and food. Yes, the planet Earth is a perfect island for man. But the very atmosphere that gives us life limits our ability to see our universe. We have great modern telescopes, but it would be of little use to build them still larger. Air currents on the surface of Earth blur our pictures. The moving air even makes the stars seem to twinkle. So scientist explorers seek new tools. Radio and radar telescopes provide a new way to see. Earth-orbiting vehicles study the Earth, and unmanned spacecraft inspect the planets. This work has led to the spaceflight of man himself. These are the things we know. Our solar system is vast. Earth is only one of 9 relatively tiny, insignificant planets. The whole system is a delicately balanced clock-like mechanism and calendar, held in orbit and regulated by gravity. Our moon is only one of more than 30 moons. Our sun is like any other star, a deadly nuclear fusion furnace. And yet, the Earth is a perfect place for man. Now we look outward. We explore space and wonder if somewhere in the cosmos there are other life-giving planets. Our search for knowledge continues. Perhaps one day, among the distant stars, we will find the answers to questions as yet we cannot even ask. Earth orbits around a star that is about 93 million miles away. The distance is just right. Earth temperatures are neither too hot nor too cold for life to exist. On Earth, there is oxygen to breathe, an abundance of water, and a fertile soil. An invisible magnetic field protects us from the sun's radiation. And our atmosphere filters out most of the sun's harmful rays. These are the conditions that are necessary to support life as we know it. We wonder if the same conditions for life exist elsewhere. We ask, what is our solar system really like? How big is the universe? To discover these things for ourselves, we'll take an imaginary flight, an impossible flight that defies both time and space. We are spaceborne. Flight time to the moon is about 65 hours. The distance, about 238,000 miles. The lunar soil is much like that of Earth. It includes volcanic ashes and rocks. There is a death-like silence here. This gray, dust-covered wasteland, pockmarked with ancient craters, has no air, no surface water. At noon, the moon's surface is hotter than boiling water. At night, it is minus 250 degrees, colder than any place on Earth. It appears that life has never existed here. We continue our imaginary flight, curving inward, closer to the sun, increasing our speed towards Venus. we catch up with the planet. The gravity from Venus pulls us toward it. Earth is now so far away. It takes our radio messages, though they travel at the speed of light, 4 minutes to reach Earth. The Venus rotation is opposite to that of Earth. Its surface temperature is 700 degrees. Its atmospheric pressure may be 100 times that of Earth. The swirling clouds are mostly carbon dioxide, with very small amounts of oxygen and water vapor. This glowing, nightmarish world has no protective magnetic field. There can be no life here, as we Earth people know it. Our flight continues. We head to the orbit of the planet Mercury. Only 36 million miles from the sun. Mercury's dark side is freezing cold. But its light side must be so hot that metals would flow in molten rivers. There can be no life here, so near the sun. And our sun. It is an atomic powerhouse with a core temperature of 20 million degrees. Each second, more than 500 million tons of hydrogen are converted into helium, and millions of tons of matter are transformed into radiant energy, which is poured out into space. Solar prominences rise like the flaming sheets of a twisting tornado, sometimes reaching 1 million miles into space. Mercury and Venus are too hot to support life as we know it. So we return, past Earth, to look outward, away from our sun, along a flight path that will lead to the red planet, Mars. Flight distance from Earth to Mars is about 300 million miles. Flight time is 7 months. Radio messages from Mars take 12 minutes to reach Earth. Mars is only 1/2 the size of Earth. Its atmosphere is clear, mostly carbon dioxide. The atmospheric pressure on the surface of Mars is equal to at least 100,000-foot altitudes on Earth. There is little oxygen and no nitrogen, the elements that make up 99% of Earth's atmosphere. Midday ground temperatures are comfortable, but the nights are far below freezing. There are small amounts of water, mostly in the form of frozen ice clouds. The South Pole is covered with frozen carbon dioxide snow, perhaps mixed with particles of water ice. Temperature at the South Pole may get as low as -200 degrees. There is no planet-wide protection against ultraviolet rays, which are harmful to Earth-type life. The surface of Mars is pockmarked with craters, more moon-like than Earth-like. There are gentle slopes, though the crater interiors are depressed thousands of feet. However, this hostile planet must still hold our best hope for finding some kind of extraterrestrial life within our solar system. We now move outward, beyond this place in space and time. We cross a belt of 100 million miles of icy orbiting asteroids. Space matter ranging from the size of dust and pebbles to rocks and islands as large as 500 miles in diameter. Next, we cross the orbit of the mighty planet Jupiter. Master of 12 moons. "300 times the mass of Earth. It is cold here. Jupiter's atmosphere is made up of hydrogen and helium, with frozen fogs of methane and ammonia. We coast on to Saturn. This huge planet has a core of rocks and metals overlaid with sheets of gases similar to those of Jupiter. From one of the 9 moons orbiting its surface, we see streaming symmetrical rings of icy fragments. Space materials, perhaps of additional moons in the process of being created, or the debris of those somehow destroyed. Out from here is the orbit of Uranus. 1,800,000,000 miles from Earth. Next is Neptune. 2.5 billion miles from home. Finally, there is the last planet, lonely Pluto. We look back. We are nearly 4 billion miles from our sun. So far away that it seems only slightly larger than a distant star. There is almost no light. The temperature nears 380 degrees below zero. Earth, man's oasis, as well as our whole solar system, is lost in the dim darkness and distance of space. But what is beyond? The speed of light is 186,000 miles per second, more than 600 million miles an hour. And yet, if we could travel at that fantastic speed, it would take us 4.5 years to journey to Alpha Centauri, the nearest star, 26 trillion miles away. In this vast wilderness of space, there are stars of all sizes, colors, and descriptions, all billions and trillions of miles apart. There are single stars, like Ross 154, smaller, cooler, and redder than our own sun. Hot blue-white stars, like Vega, remain uncounted. As they lose their energy, some stars grow to be giant red suns like Antares. Larger than the entire orbit of Mars. Eventually, this star may collapse to form a tiny white dwarf star. So heavy that a handful would weigh 25 tons on Earth. There are pulsating stars, like Mira, that contract and expand at regular intervals. Their light output decreasing and increasing. There are nova and supernova, star tragedies of vast proportions. Nuclear explosions in which a star blows off into space excess gaseous material amounting to several times the mass of our solar system. Stars known as pulsar stars emit bursts of radio energy at regular intervals. Some at frequencies up to 300 times each second. There are double, triple, and multiple stars. And globular star clusters that may contain 100,000 stars. In this vast arena, there are glowing shrouds like the Great Crab Nebula. Enormous clouds of gases and dust that reflect in the short-wave light of blue-white stars. It would take jet aircraft 150 million years to cross this great expanse. Other nebulae, like the Horsehead, have no nearby stars for illumination. Thus they are seen as dark silhouettes. Beyond here, there are more stars, all converting matter into energy. Some shed hydrogen and helium in glowing spirals millions of miles long. All we have seen are members of our own Milky Way, a galaxy of 100 billion stars, 80,000 light years in diameter. Once each 500 million years, the galaxy rotates like a giant wheel. Our own star, the Sun, and our solar system is 30,000 light years from the center, lost in the haze of individual stars. Still we move outward. Another galaxy of stars is Andromeda, a complex similar to our own Milky Way. On this trackless road, there are millions of galaxies. Each with its own million, billion stars. We are 50,000 billion miles from Earth. But there is no known boundary to the cosmos. We may be looking towards infinity. What captive island planets orbit these uncounted stars? If only a few of the stars have planets, and only a few of the planets have pleasant climates, what beautiful civilizations might spring and thrive there? We do not know. So man continues his search. He journeys to see what he will find. Perhaps one day, in a cosmos so vast as to defy everyday measures of space and time, he will find the answers to questions as yet he cannot even ask.